Hello, this is Christina Long, and this is the Science 411. Today's video is over phase changes. There's something called the kinetic theory of matter, and it basically means that matter is made up of particles which are in continual random motion. And then the question becomes we know matter is anything that has mass and takes up space, but what are the four types of matter? And those are going to be a solid, liquid, gas, and plasma. You're probably most familiar with the first three, less so with plasma. In looking at the first one, a solid has a definite shape and volume. They're normally organized in a crystalline solid. There is something called an amorphous solid, and that's a softer solid that doesn't really have a pattern. And an amorphous solid, it starts out in one shape, and over time, or because you apply pressure to it, it's going to take on another shape. The word amorphous means without shape. An example of an amorphous solid would be like Play-Doh or silly putty. It starts out as one thing and changes to another. They're packed, in general, solids are packed very tightly together, and they tend to vibrate in place. The next type of state of matter is a liquid. And in liquids, particles, they have a definite volume. They do not have a definite shape. Instead, they take the shape of their container. Liquids are a fluid. Now, a fluid can be both a gas and a liquid. A fluid means actually being able to be poured. Molecules in a liquid are far enough apart to slide over one another. A lot of times it's said that they're sliding past one another. Energy level in a liquid is going to be greater than a solid. Now, when we talk about energy level, we're talking about kinetic energy level because the molecules are moving around more than in a solid. The third one we've got is a gas. And gases have no definite volume or shape. They tend to spread out to fill the entire space given. So they try and fill their container. Gases can be squeezed together. This is called compressed. They are compressible. And the particles tend to be very far apart. They can move freely. They collide frequently and have lots and lots of energy. Now, what type of energy? We're talking about kinetic energy. So gases, particles in a gas have high kinetic energy. And they can be compressible. They're the only state of matter that is compressible. Particles in plasma. Plasma is a lot like gas, but the particles are electrically charged. They have an indefinite shape and volume. They are extremely energetic. Lightning is an example of plasma, and it's used in fluorescent light bulbs and neon lights. Now, states of matter. If you take a look at the diagram, when you go from solid, liquid to gas to plasma, you're adding energy in each of those things. So as a reminder, a solid is tightly packed in a regular pattern. They vibrate, but they don't move from place to place. And then you add a little more energy and you get to liquid. They're close together with no regular arrangement. They vibrate, move about, and slide past each other. Then you add some more energy and you get a gas. And these are well separated with no regular arrangement. They vibrate and move freely at high speeds. And then you add even more energy, has no definite volume or shape, and is composed of electrically charged particles. What is a phase change? A phase change is a change from one state of matter to another. They are physical changes because they do not affect the chemical makeup of a substance. That is exceptionally important. Now, the picture over on the right is another example of a phase change diagram. It's not as detailed as some others that you may see, but it definitely does the job. What happens during a phase change? Heat is either absorbed or released. And heat energy is released as molecules slow down and move closer together, and those are called exothermic processes. And when heat energy is absorbed as molecules speed up and expand, those are going to be called endothermic processes. Melting. Melting is a phase change from a solid to a liquid. The molecules speed up, they move farther apart, and they absorb heat energy. So it is an endothermic process. Freezing is going to be the opposite. It's a phase change from a liquid to a solid. Molecules slow down, they move closer together, and they release energy. So freezing is an exothermic process. Vaporization or boiling. It's a phase change from a liquid to a gas, and it occurs at the boiling point of matter. Molecules speed up, move farther apart, and absorb heat energy. That is an endothermic process. Evaporation is a phase change from a liquid to a gas on the surface of a liquid, and it's a type of vaporization, but where it takes place is a little bit differently. But it's still, the molecules are still speeding up, they move farther apart, and they absorb heat energy. So evaporation is, again, an endothermic reaction. Condensation. Condensation is a phase change from a gas to a liquid. Molecules slow down, move closer together, and release heat energy. A condensation reaction is going to be an exothermic reaction. Sublimation. Sublimation is a phase change from a solid to a gas, and molecules speed up, move farther apart, and absorb heat energy. So this actually skips the liquid stage, and it's exceptionally endothermic. Deposition. It's a phase change from a gas to a solid, and it's the opposite of sublimation. The molecules slow down, they move closer together, and they release heat energy. It's very exothermic. You've got another diagram showing the different phase changes. Now, the two that are not included are going to be sublimation and deposition there. But in the blue, heat energy is going to be released, and those are going to be exothermic reactions. So an example, the other example of an exothermic reaction where it's going from a gas to a liquid, a gas to a solid, that's going to be deposition. And again, it's exothermic. And then the opposite of that, the ones in red, melting and evaporation, are going to be red because they are endothermic. That would be sublimation. And again, if it's red, it's endo. And if it is blue, it's exothermic because it's cooling. All right. And then we get to the most common phase change of water diagram here. And this is the one that you really need to make sure that you know, okay? And one more thing, if you were to add in the extras, remember a solid to a gas, a sublimation, and then a gas to a solid is going to be deposition. So you've got some questions there. Why is there no change in temperature during a phase change? Well, that's pretty important. That's super duper important. The reason there is no change in temperature during a phase change is because instead of the energy being released or gained, whether it's an endothermic process or an exothermic process, instead of that energy being released or gained, it's being used to create order in a molecule or to break bonds. So let's say that a gas is turning into a liquid. It's condensation. And you take a very hot gas and you cool it. You cool it, and then it begins to condense. Those molecules don't have a lot of order, but a liquid does have more order than gas, and so those molecules are not going to order themselves. Instead, the phase change uses the energy that was released as it was cooling, as the gas was cooling. Instead, it uses that energy to bring order to the gas molecules to make them into a liquid. And while that's happening, if you notice, condensation and evaporation happen on a flat line of the graph. And it's because the temperature stays constant. Because while the substance is in an actual phase change, it's either gaining or it's either using the energy to create order or to create disorder, to break apart molecules in doing the phase change. So phase changes are always going to be on the flat lines, whereas the states of matter or phases of matter are going to be on the slants. That's an exceptionally important concept. Define melting and boiling point. Well, melting point in water is 0 degrees Celsius, and it's the point where solid molecules begin to break apart and they form more mobile and active liquid molecules. And boiling point is going to be at 100 degrees Celsius, and that's where liquids are going to begin changing into gaseous molecules of water. What's the melting and the boiling point of water? Well, for melting it's 0 degrees Celsius, and for boiling it is 100 degrees Celsius. And what temperature does water freeze and become a solid? Well, it still happens at 0 degrees Celsius. The melting point and the freezing point of water are still the same thing, and it's just a matter of whether or not you are increasing or decreasing the temperature, whether or not you're doing endothermic or exothermic processes. So I hope this has been helpful. I hope you guys have a great day, and I'll be back soon. Thanks.